Show that the pairs 0, 2 and 6, negative 2 are solutions of 2x plus 3y equal 6. To show that a pair is a solution, we substitute, replacing x with the first coordinate and y with the second coordinate in each pair. So for the first point, 0, 2, we will replace x with 0, y with 2, and then simplify, multiplying first. 2 times 0 is 0, 3 times 2 is 6. Adding the two together, we have 6 equals 6. Here is our proof that in fact 0, 2 is a solution to this equation. Proof for the other point, we'll do the same thing, letting x equal 6 this time and replacing those values in the given equation. We have plus 3 times the y value, which here the y value, the second coordinate in this ordered pair, is negative 2, and we're testing to see if it equals 6. Simplify multiplication first. We end up with a 12 and a negative 6. Simplifying the addition, 12 plus a negative 6, or 12 minus 6, leaves a 6, and 6 equals 6, which is also true. So there's our proof that these 2 points are solution. We're then going to take these points and graph them, which will result in a line. The line is called the graph of the equation, and it represents all solutions of the equation. So we're going to take those 2 points. The first one was 0, 2. The second was 6, negative 2. And we will plot those on this graph. So 0 displacement in the horizontal with a positive 2 in the y direction results in that point. 6 positive in the x direction with a negative 2 in the y results in that point. Taking a straight edge, we will connect those points, which is giving us a line which continues infinitely in both directions, and this is an infinite set of points that are solutions to the equation. So to find another pair, we'll just look for a convenient intersection, and it appears that the point 3, 0 is part of this graph, as well as any other ones, but these points are harder to make an accurate estimate of the coordinates. So again, this line that we graphed intersects right at an exact value on the graph. So another solution is 3, 0, and we can further test that for verification by replacing the variables with the value here. So 2 times x plus 3 times y. Does it in fact equal 6? Multiplying 6 plus 0, sure enough, this is another solution to the equation, as well as any of the other ones, only as I mentioned, they're a little bit harder to read when they aren't right on an intersection from the graph.